Hello and welcome to Luckymath. I'm finally back and I'm back with a new playlist. It's gonna be on linear algebra and we're gonna get started with the most prominent object of linear algebra, which is the matrix. So if somebody asks you what is a matrix, you can answer the following. It is an object with some brackets, often pretty big fat brackets. And in between these brackets there is an array of numbers. So for example 5, 3, 2, 1, 2, 1. So this is a matrix. And if you want to specify what kind of matrix this is, then what you can do is you count the number of rows in this matrix. In this case we have 2 rows. And you can count the number of columns of this matrix, and in this case we have 3 columns. Now if you want to write down mathematically what kind of object this is, then you can say that this is an element, and you specify in what field these numbers are defined in, so if these are real numbers or complex numbers. So in this case we can just say these are real numbers, right? So we have the real numbers, and now up here you can write down the dimension of this matrix by saying first the number of rows. So we have 2 rows, and then you specify after this cross what number of columns you have, namely 3. So this matrix is an R2 cross 3 matrix. Let's do a second example. Suppose we have the matrix 2 plus I, and then 3, 1 plus 2I, 4 plus I. In this case, we can say that this is an element of, well, we can't write R as the field in which these numbers are defined in, because these are obviously complex numbers. So we need C as our field. Now we can again count the number of rows. We have 2 rows. We have 2 columns. So this is a square matrix. Oh, just 1, 2 is enough. This is a square matrix and its dimension is 2 cross 2. 2 rows and 2 columns. Now there are certain matrices which I'm sure that you have already seen. For example, let's say we have an object x in Rn. So this is a vector in Rn. And so far you have written these vectors down either as a standing vector, for example x1 until xn. So these are the entries of this vector if the dimension is n, so we have n rows. Or you have written this vector down as a lying vector. So for example as x1 until xn. And it didn't really matter how you wrote it down, right? So who cared? But now you have to care, because if you look at these objects as matrices, which you obviously can, it is a big bracket and there are some numbers in there, then you have to be careful which object you need or you are looking at, because they are different. So if you count the number of rows in this case, in the standing vector case, you have n rows. But in the lying vector case, we have only 1 row. And then, if you count the number of columns in this standing vector, you have obviously 1 column. And in the lying vector case, we have then n columns. N columns. Therefore, these objects are not the same. So this object here, the standing vector, would be an element of, we can say R again, because we defined our vector in R. It could have been C, what you like. So it would be R. And then we don't just write n, but we really write down the dimension the same as up here. So we have again n rows, but then also cross 1 column. So this is an n cross 1 object. And the same we can do here, and we see that this is an R1 cross n object. So then let's do one more example. You're gonna see that you really need these kind of objects when you do then matrix multiplication, and this I think is gonna be the next video I'm gonna do on linear algebra. So one more example of matrices would be, let's say we have a scalar, lambda element of R. Could be C as well. I just pick R for simplicity. So then it actually doesn't really matter if you simply write lambda or you write lambda with some brackets around. So you see that this is a matrix as well, right? Namely, this would be a R1 cross 1 matrix because we have 1 row and 1 column. And so it doesn't actually matter if you put these brackets or not, you still look at this object as a scalar. But this is actually a matrix as well, so you can look at scalars also as a matrix. Same for vectors, and the general dimension or general how you would write down a matrix in general is you can say you have a field and the dimension would be n cross m, where n and m don't have to be the same numbers obviously, and n and m are natural. That's it for this video. Thanks for watching. Rate the video, subscribe, and see you soon again on Luckymath.